making Shokupan, or basically white bread that tastes slightly better. And we will also be going into the science behind how Shokupan rises and how it bakes. So to begin with, we have our flour right here, and we'll start mixing in our dry ingredients. We have 30 grams of sugar, 4 grams of salt, and 6 grams of our active dry yeast. As you can see, I've just put the sugar and the salt and the yeast out into little wells on the side, being careful so that the yeast doesn't touch the salt, just because the salt will kill the yeast. Just really quickly mix everything into the flour. And then we can put our wet ingredients in. So we'll just pour the 160 grams of water and our 100 grams of heavy cream. And then we just need to mix this together. While we're kneading our bread, let's discuss the development of gluten and why we need to knead bread. Gluten in bread comes from the two components that form gluten that come from the flour, gliadine and glutamine. When you add water or a liquid that hydrates these two and mix it together, it sticks together with a combination of inter- and intramolecular bonds, specifically disulfide bonds, and a combination of hydrogen bonds, some ionic bonding, and some dipole. And it forms our gluten complex. Then we knead the dough so that we can stretch and break the proteins that have combined together so that we can better align it so that it'll finally trap the gas that we want to keep to help our bread rise. So we'll keep kneading this dough until the gluten inside of it has properly developed so that it doesn't tear apart like this, but instead will stretch a bit more. Now that we've kneaded this for 30 minutes, you can see that it's starting to get stretchier, whereas earlier it would just kind of tear apart. So now we're going to mix in the oils, in this case some unsalted butter, 25 grams at room temperature. This helps add a lot to the flavor, but we have to add this after we've already developed gluten in the dough because the oils inhibit some of the proteins from aligning properly into that gluten complex that we want. So we have to add this after we already have what we need for the gluten. So we're just going to dump this into the dough and start to knead it together for another long time until the butter stops slipping out of the dough and the dough is back to a glossy dough ball. Okay, the dough is very nice and elastic now. If we poke it, it kind of springs back and it's a lot stretchier compared to how it was when we first started kneading the dough. So now we can let this rest so that the yeast can now do its part. So we'll just put this into a little ball like this, grab this, plop it in, and we can loosely wrap it with some saran wrap or a damp tea towel. And then we just let it sit so that the yeast can do its thing. While our bread is rising, let's discuss how it's rising and the importance of yeast. As you know, we put sugar into our bread dough, and that sugar is sucrose. In order for the yeast to be able to use the sugar first needs to break into glucose and fructose, specifically glucose. And that comes from the hydrolysis of sucrose, where this glycoside bond gets broken. And it comes from an enzyme that's also in yeast called invertase. Once we have glucose, the next step is glycolysis. The end goal is that we want our glucose to turn into pyruvate so that we can have the yeast interact. The pyruvate interacts with the enzymes from yeast and forms our carbon dioxide, which is what we want to help the bread rise. And it also forms ethanol, which eventually gets baked off once we put the bread into the oven. Okay, and now that our dough has risen for the first time, we can just knock back the air, knead it back together for a bit. We can turn this out, and we can kind of shape it so that it fits into this kind of shape. Just fold it in like this. Put this in here like this. And then we cover it and let it rise again. We let it rise a second time so that the bubbles are finer and that the gluten structures are better aligned before we bake it. After another hour of proving, we can now put this risen dough directly into the oven at 355 degrees Fahrenheit for 30 minutes. While our bread is in the oven, we can discuss how the crust forms and why it's golden brown, and that's because of the Maillard reaction. The Maillard reaction involves a reducing sugar, an aldehyde or a ketone, such as glucose, which can donate electrons, and an amino acid, which donates the amine group. These two form either a Haynes or an Amadori intermediate. The Haynes is from if the reducing sugar is a ketone group, or if it's an aldehyde, then it's an Amadori. And eventually it rearranges to aromatic compounds that end up as melanoidins, which is what gives the crust the brown color. And now that our bread is completely cooled, we can cut it open. And you can see the bubbles that the yeast formed and how it's tight, complex, so the gluten has helped capture it. It's not very large bubbles. And the crust, which is nightly golden.